So the session is currently in progress and it's recording. And we'll start with Anypoint MQ. It'll take about 30 minutes or so. We have some demo use case prepared, and then we'll move towards a topic on good practices while documenting your Rammel and API specifications, which will be led by Ahmed. Thanks. In introduction, Anypoint MQ is a cloud-based service that provides message-based integration between two or more applications. It's fully integrated with Anypoint platform and is available in multiple regions with role-based access control and encryption at rest for the data. The data is stored, persisted in the cloud, different regions based upon where you choose to host the services. The Anypoint MQ, it supports message persistence up to 10 megabytes and provides the connector support and APIs to connect to the infrastructure, the messaging infrastructure, and consume the messages or publish the messages to drive the integration in a decoupled systems or decoupled ways. With Anypoint MQ, there are, just like with any other messaging system, there are different attributes that Anypoint MQ supports. It provides first the decoupling between the systems, be the client and the server systems or the end systems, whatever we may want to call it. And it is suited for use cases where we need to have data captured from multiple sources into a single source and then work on that data, or have messages broadcasted from a single source into multiple targets. And additionally, messaging as a whole, it provides with capabilities like how we can control the throttling, reliability, which means that both client and server who are working to process and request the messages, they can work independently at different speeds, but yet be part of one complete end-to-end transaction. And importantly, it provides us the reliability that we need in today's world between the different systems, how the messages are interacting between the two systems. If you have any questions, please feel free to drop into the chat, and we'll take those questions later as well. In Anypoint MQ, these capabilities that we saw as a messaging subsystems are provided through different components, either through the messaging queue or exchange. The queues are of two different types. You can have a standard queue, which is mostly used to decouple the system, have an asynchronous communication between the two systems. And the way the queues work is, it works in a quality of service which is set to a best effort mode. That is, when the message is persisted into a queue, it is guaranteed that it will be processed at least once. Where you have a Fifo queue, which talks about the same queuing mechanism, where you have a, let's say, a sender which is publishing a message to a queue and set of messages. And if you want to preserve the order of the consumption in which the messages were published or persisted in the queue, we use a mechanism of a Fifo queue. This queue provides us with the mechanism of exactly once. So if you have a use case where you need to persist messages as well as process them in an order in which they were persisted, the use of Fifo queue is recommended over the queue, over a standard queue. Then you have a different pattern which can be realized through exchange, where you have a single message source which is being consumed by different applications in more or less a broadcast fashion, where you are able to bind different queues into a single logical entity, which is realized through exchange. In order to connect to these artifacts, be it queue, exchange, or a Fifo queue, using a Mule application, you can connect via a MuleSoft connector, which is an Anypoint MQ connector. And then Anypoint MQ connector provides with different functionalities. That is, either you want to publish a message or consume a message, or if you would want to do a subscription or a listen on an event and then trigger or spawn off an instance. We will see how these features interact in an end-to-end scenario as well in subsequent sections. One of the attributes of the messaging that we noted in the system was reliability. So what exactly is reliability and why do we need the reliability in today's world? So consider a scenario, right, where you have a highly business critical functionality that needs to have an uptime, and it's integrating with some backend systems. In order to ensure a good customer experience, that requires a reliable system. That is, one aspect is from reliability that no message should be lost, or there should be no or zero message loss. And the other part of the reliability also comes into picture is when you have two different systems, heterogeneous systems, they are bound to work in a different speed, at a different speed. They would have a different SLA. And meaning that if an end system has an SLA of, let's say, processing 10 transactions per second versus a client who is publishing messages at 100 transactions per second, you also need to ensure that none of those transactions are lost, as well as your end system does not get bombarded and degrades the performance because it is not able to scale to the expectations of the SLA set that the client is publishing to. How we are able to solve or work on these use cases to eliminate that message loss is through the messaging layer. So a messaging layer is introduced between a caller and, let's say, a third-party application or an application, which provides us with the persistent storage, a temporary persistent storage. And how this works is a pattern. A client initiates the request. Once the request is initiated, a quick validation, a sanity check can be done from a data validation perspective or side or standpoint, and then published to a messaging layer, in this case, an Anypoint MQ. Once the message is published, the client is acknowledged with the success, and the processing of the message can take place in an asynchronous fashion, which is how, one, the reliability of the system is established in the sense that even if the end system is down, the message is still persisted. The client has published the message. It is guaranteed that this message will be processed at least once. Now, there could be a scenario where the publish itself fails. In that way, the message is not persisted, but the client is given acknowledgement in an error scenario, or client receives an error to retry, or let's say even to persist the message elsewhere. So in either cases, the message is still not lost. The client has the information. It requires, or it maintains the state of what has actually happened to the message. Let's walk through some of the platform components and Studio components, how the messaging infrastructure is realized into the Anypoint platform. I believe you're still able to see my screen. Yeah. So Anypoint MQ is an entitlement. It's a subscription that you can set. Once you have the subscription and the proper role and responsibility to access the Anypoint MQ, you can log in to the Anypoint MQ, and this is the infrastructure, the UI that you can use to set up your different components. In Anypoint MQ, you have queues, exchange, and Fifo queues that we discussed earlier. Like in the initial slides, we talked about the availability of Anypoint MQ being a cloud service. It is available in different regions. So based upon the different factors, like where your data centers or where your deployments are, in which geographical location you're located, the customers or the clients are located, you can select the different region, the appropriate region, and create the different artifacts. Just to simply check how we can create, it's a very self-serve capability, minimum attributes required or a very simple wizard, you can click on the button and say queue. Let's say we want to create a queue. You can create a queue and specify an ID. So this has to be a unique ID across the infrastructure that you are holding. Let's say we give a name as demo order queue. There are certain different attributes that go along with when you're setting up a queue. One is the message time to live. This setting, TTL, is specifying that what is the duration to persist the message, that how long the message can be persisted in the queue. Maximum that we can go is, I think, 14 days. And then another attribute is the default acknowledgement timeout. So how this works is, let's say we have persisted a message and there is a subscriber to that particular queue, in this case, a demo order queue. How long the infrastructure, or let's say the MQ subsystems, should wait to get an acknowledgement that the message has been successfully processed, subscribed, or not. So in this case, it's listed as 2 minutes, meaning that the Anypoint MQ infrastructure, the subsystem, would wait for a response time from the subscriber for about 2 minutes before discarding the message or before taking any next steps on what happens if an acknowledgement is not received within those 2 minutes. You can also encrypt the message. The encryption is using the AES standard login. The data in rest or data at rest would be encrypted. And then you can also assign a dead letter queue, meaning that, let's say acknowledgement is not received, or a negative acknowledgement is received, or an error is received. The message should not be lost, but it should be ingested into a dead letter queue, which can be used to process the message later on at a reprocessing stage. Similarly, you can create a Fifo queue as well. In order to access all these, we need to have an access token, or let's say a mechanism, which in Anypoint is governed through client apps. So client apps provides you with a means to connect to the underlying resources, be it Fifo Queue, Anypoint MQ queue, or an exchange. This works based on the client app ID and a secret ID. So an advantage over this is the consumption of messages is being secured both at the environment level as well as the business group level and the region level. So you need to have a proper authentication set in order to retrieve those messages. So this is at the platform level. Similarly, we do have configuration available at the studio level as well, which is the place where you would be designing the flows. So the connector is available once you download the connector through Exchange or through a POM XML entry. It is shown up as Anypoint MQ as a connector and provides at a very high level different functions or operations. One is to publish. As name suggests, it's used to publish a message. Let's say it's used to publish a message to the persistent store. And then how this publish works is, one, when you drag and drop a connector, you specify or you create a connection to that infrastructure. One, in order to create that connection, you need to specify the app client ID and the secret. Of course, this is not a recommended practice that you specify it over here. You need to specify it using properties file and have proper encryption. So this is just for demonstration purposes. So once you create an Anypoint configuration, you can use it to connect to the underlying infrastructure and specify the destination in this queue and queue, the name of that queue, and what's the message that we need to persist. In Anypoint MQ, the messages are persisted in a string format. So CSV, JSON, everything works. So, and you also have the ability to specify some user-driven properties as well. Once you publish the message, there could be another scenario, which is going to listen to that particular message. So here is a subscriber. A subscriber is an operation which initiates or listens or continuously polls for any point on an Anypoint MQ artifacts. And then based upon the different parameters, the queue name, what's the total, let's say how long you would want to poll for, what are the total number of messages that you would want to poll for in a buffer, all that can be controlled and throttled, which is suited for your backend system. So once the consumption is through, this consumption along with the time to live set over here and the default acknowledgement time determines what happens once the message is consumed. So let's say in this particular case, a message is consumed, a further processing would happen. If the processing is successful, we are going to acknowledge it with a success. If it's not, we're going to say that, okay, something went wrong. We don't want to remove the message from the queue. We don't want to lose the message. Surface that back to the queue. Maybe some other consumer is there that can pick it up. Or if the message has been already retried and it's still not gotten a successful acknowledgement, reroute that message for manual reprocessing using a dead letter queue. So at a very high level, you have connectors, which provides with publishing a message to Anypoint MQ and a subscription of a message from an Anypoint MQ and controlling of the acknowledgement, either success or in a negative scenario, whether the message should be deleted as it has been successfully processed, or it should be still persisted that it has not been processed. It should be retried later on. Moving on. Let's take a quick look at the demo, that how the persistence layer adds the reliability and how it helps and scales with the producers and how Anypoint MQ delivers that functionality. In order to realize this use case, we've come up with a fictional use case where we have a system API. Let's say this is the end system, and this is just a mock. And a client has a need to make use of this API, which is connecting with some backend system. One way is for an application to directly consume through the HTTP listener. But in that case, what happens is if this application or an API is down, the client has the responsibility to maintain the state of the transaction. It has the responsibility to retry every transaction, and there is persistence layer that has to be established. The other way is to make use of messaging as a layer. The client would persist the messages into a queue, and then the Anypoint MQ would subscribe, or an application would subscribe to those messages, and based upon the error scenarios, invoke that system API or an end system, and then acknowledge or negative acknowledge the system. In order to demo this use case, what I have is I have created a queue, which is a webinar order Fifo Queue, and some set of applications which are subscribing to that Anypoint MQ. In this particular case, the use case that I want to demo over here is that even if the end system or an API is not available, the messages are not lost. So to mimic that, I have shut down the subscriber. And we'll see there are currently 2 messages that are still persisted and not lost. So if I continue to add more messages into my Fifo queue, let's say I'm adding 2 more messages in an array. So the count should increase to the Fifo queue as 4. So 2 new messages were added, and we see the message has been persisted even when the subscriber was down. So that's the advantage of bringing in the messaging layer. One, the persistence, and based upon the rate of control, the messages can be consumed as well. The second example or the second artifact that you want to talk about is from a scaling perspective, that how messaging can bring up that scaling functionality. So same scenario, consider messages are being pushed to a queue. A lot of messaging are being pushed to a queue, and we have a subscriber, which is, we have we have a subscriber, which is, let's say, listening to that particular queue. So currently, if you see that this subscriber is polling to the webinar MQ and looking for messages using the connector, and the connector internally is using the platform API to connect to it. Currently, there are no messages to fetch. There are no messages into the queue. So what we'll do is we'll start publishing some messages into the queue. And to demo that, what I'm going to do is run some load of about, let's say, 1,000 messages. And what we'll see is the messages would start persisting into the layer, into the persistence layer, and they're also getting consumed. So if you see the request ID, all those messages are being consumed. If you see Ori, these have been consumed by the subscriber. So let's say we get into a situation where we feel that the messages are being persisted at a very high rate, and the application is not able to scope up or is not able to scale to that requirement. So what we can also do is we can scale the application, create more workers. In this case, it's already running on 2 workers. So they would behave in a competitive consumer fashion, but it still is working in a best effort scenario. So there could be some duplicates as well. You can also add more consumers to it, meaning what I have done is I also have a setup on an on-prem system where I'm running the same consumer, and we'll monitor and see how the same queue can be subscribed by 2 different applications or 2 different consumers, and both work in a competitive consumer fashion. So if I go into, applications. And look for my application. I'm going to start this up, and we'll start monitoring the logs as well. So as soon as we do that, we'll see the messages are being consumed by multiple sources now, the Cloud Hub one as well and the on-prem as well. So this is how you are able to scale, bring in that concurrency control, the throughput control between the client and the consumer. One of the other features that messaging provides us is the feature of a circuit breaker, right? So in a typical scenario, it's not just about a 0 message loss. We also need to ensure that the end systems that we are trying to connect using the messaging layer are not bombarded when there is a downtime of that system. We also need to ensure reliability, the uptime of that system. We are not publishing messages that would continue to error down. So consider a case when the end system invoked through that subscriber is causing issues or is down for maintenance. And we don't want to bombard the messages and continue failing the transactions. So how do we ensure reliability? How do we ensure the messages are not lost in that particular case? How do we prevent or make sure the health of the system remains intact, even when one of the systems, the end systems, is not working in totality? So circuit breaker is one of the patterns, and this neatly fits into the Anypoint MQ world as well. How this works is, in a normal scenario, when the messages are being consumed, the circuit is tripped closed, and the messages are consumed and passed on to the end systems. You can configure a connector which says that the Anypoint MQ subscriber connector, which says that if message has been subscribed by Anypoint MQ application, however, fails to connect to a downstream system for a particular error, let's say on a given error, let's say the same API which we were calling is giving a lot of timeouts. If I receive more than 2 errors, more than 2 HTTP timeouts, do not consume the messages for a minute or a given interval. So based on the error types, the threshold of the error, and the trip timeout, we can also control and unsubscribe the subscription from the source. In this case, what would happen is the message would still remain in the persistent storage, will not be pushed to the end system, thereby maintaining the sanity and no message loss. In between all this, let's say when the trip or the circuit is open, let's say the threshold has reached on that particular error, the infrastructure or the Anypoint MQ system would try in a timely fashion to test the connectivity and end-to-end transaction for a given message, for one given message. If that's successful, the subscription of the remaining messages would continue. If not, the circuit would still trip to open. So 3 important parts to note in this particular case in a circuit breaker to implement the circuit breaker are the error types, the threshold, and the timeout. And we'll see how we can model that in a connector. So in a same scenario where let's say we have a system API, this is being invoked, and we'll mimic that this system API goes down. What happens in that particular case? So subscriber is calling to an application in a successful scenario. It's going to make a call, do an acknowledgement, and close off the transaction. The message would be deleted from the queue. In this particular case, when we are mocking that the system API goes down, the try handler catch block would be invoked. It is going to negatively acknowledge the transaction. Along with that, what it's going to do is it's going to invoke a circuit breaker functionality in the subscriber mode. Now, based upon the configuration which is set in this particular case, timeout. So if this end service does not respond within a certain timeout, or it gives a timeout error, and it gives two different transactions fail, the circuit is going to open up for a minute and no further messages will be consumed. Now we'll try to model this, how this can be modeled. So in order to model this, what I'm going to do is I'm going to shut down the system API. And let's see if there are any pending messages. So there are no pending messages, but the API is down. I'm going to rerun the test again, which is going to persist the messages. So we should see some messages getting persisted into the queue. So you see we have some in-flight messages, and some messages are going to get published as well. Once these messages are being published, and if we monitor the logs of the MQ subscriber, what we're going to see is, sorry. We'll see over here. What we'll see is a few log in which we'll say that the circuit is open. So if you see over here, the circuit break is open, circuit is open, it is going to skip fetching the messages. So no new messages would be consumed until the test or the circuit is back closed again. So once we refresh, what we are going to see is that the circuit is it's still open. It'll remain open for a minute. No new messages would be fetched. But after a while, it is going to do a test on this to see if the circuit is still open or closed. So if you see, it's going to make a test, and we should be able to see the test as well somewhere. Yeah, so circuit is half open. This is the scenario where the testing was done to see if the messages can be processed successfully or not. So single message was dispatched. However, in this particular case, okay, one was received, and the circuit would have been tripped back again. If you see, we should have a message saying that circuit is tripped again. So yeah, so it's tripped back again. So this is how you can prevent or make use of circuit breakers to maintain the reliability of the end systems and also not lose the messages. Moving on. Okay, so we have done this. So how, again, refactoring into the log, how it works is when the circuit is open, it will not fetch any more message until the time has passed. Once the time is passed, the waiting time is passed, the circuit is going to do a test using an half open state, where it's going to dispatch a single message. And if that test fails, it's going to open up the messages for consumption. If not, the testing would still fail and no new messages would be open up for consumption. The message which was received for testing would be pushed back to the queue. Again, it starts, everything is normal, the circuit is closed. Based upon the error type threshold and the timeout, the circuit would open. It would do an half open test. If everything works, if the test is fine, it would close the circuit. Otherwise, it would remain, the circuit would remain in an open state. A few of the lessons learned. There are two different ways in which the messages can be retrieved. One is in a best effort fashion. That is, as long as the message is persisted, it is guaranteed the message would be processed, but it would be processed in a best effort way, meaning that there could be a duplicates as well. However, you have a way, if there are use cases which demand for messages to be processed exactly once, you can make use of Fifo queues in that particular case. Based upon the use cases, you need to ensure that the time to live property and the message acknowledgement time to acknowledge the message has been successfully processed or not and should be deleted or not should be tuned based upon the use cases. And so is the batch size and the polling interval to control how many messages can be controlled or how many messages can be polled or fetched at a single API call from Anypoint MQ messaging service. Along with that, if you have a hard fast requirement where you would want to proceed or process the messages in a single threaded way, then the mule flow concurrency parameter should also be kept into mind. So mule flow concurrency parameter, along with the batch size and the polling interval together, control and govern the performance, throttling, and throughput and the concurrency of how the messages will be processed. The retries is something that you would want to retry as well, monitor as well. So how many times a message should be retried before it is published or discarded or sent into a dead letter queue. Currently, Anypoint monitoring does not offer a enriched way to monitor. So make sure that you're monitoring or create a flow which is going to monitor for a dead letter queue. You can make use of Anypoint platform APIs as well to ensure that there are no messages, or if there are messages, how you're going to and when you're going to reprocess those messages. In order to utilize the circuit breaker, make sure that the trip time and the time to live call in the queue messages is appropriate. You don't want to have a very shorter trip time if you know that there is a downtime maintenance going on. Or if you feel that, okay, this is an intermittent issue, you can configure the trip time and the number of errors simultaneously. We can take up any questions if we have, or we can move to the next part. Okay, so I see questions are more or less answered. But if there are any further questions, we are happy to take those, or we can open up the chat as well now. Okay. We'll move to some trivia now. So this is like a first come, first serve. So we'll have some questions, 3 questions, and one of them would be the best answer or the correct answer. Whosoever answers it first will note down, and we'll have some goodies coming your way. If you are ready, here is the first question. So Anypoint MQ topics can be used in message broadcast scenarios, true or false? Okay, so I don't see answers coming in. First was from Jayashree, but the answer is false. It's Exchange. There are no topics as such. So we proceed to the next one. And since this was a true false, so what we'll do is we have to give 3. In the next one, we'll monitor for the first 2 answers, whosoever answers the first 2 correctly. Which three attributes control the working of a circuit breaker? Okay, so Srinivas has the correct answer. Third one. Which of the following represents the state of a circuit breaker? Okay, so Nitesh and Ankur have the correct answer on this one. All right, so this is it for me. I'm going to stop the share and pass the ball to Ahmed.
Hello, how are you doing, everybody? My name is Ahmed Tufaha, and I'm an independent consultant with the community of independent consultants in Paradigm. So I'm going to begin with API documentation. So I'm just share my screen. All right. So I hope you guys can see my screen. So for API documentation, we'll talk about 2 things first: API exchange, and then we're going to go ahead and talk about RAML API branching. So why is API documentation important? Because it helps clients know the purpose of the APIs, and so developers can be able to implement the APIs. So this is important because if you had bad documentations, it would cause some trouble for somebody else coming into the team to be able to use that API. Now, what makes a good documentation? Kind of criteria that you should look for. Make sure the templates are consistent throughout all your APIs, easy for them to read. And when you do request and response examples, make sure there's synthetic data. Don't just give any type of data that doesn't really have any meaning to, for example, you have address. You just want to put like a all down. You want to write a similar to a real address. Also, a detailed security and policy used within the APIs. That is also important if you're using security policies. A list of required or optional parameters. So your query parameters, your examples for that as well, URI parameters. If you also for headers as well, mention those. A detailed error handling. Now, error handlings are very important, and from company to company, they could mean something different. So make sure you explain what that means to your company. And a contact form. Someone to contact about the API. So you want to have somebody who is the lead of the project, or somebody who'll take charge of answering any questions. Also, adding tags. Now we're going to go into Exchange, and I'm going to give you examples of a bad as well as a good API documentation. So I want to start with a bad example. Oh. Sorry about that. Get off. Okay, so as you see here, this is a bad example. It has no tags. It has no description on your homepage. When you even go to the auto-generated documentation that Rammel gives you, it looks bad. The example is bad as well. So there's nothing on this right here that looks good. This is not going to give you customer success. So this will be a good example. As you see here, gives you an overview of the API. Now you have two options. You can have everything in your home and just give a example for like overview right here, your query parameters, the security you're using, the contact support, and all that kind of stuff, all in just the home. But I personally like to separate them. So when you go into your summary of API endpoints, after you go to your overview, you just basically give a short but sweet information on the method you're using, as well as the resource that you're using within this API, with a short description. Now, some APIs, they are dependent on other APIs. So if that's the case, you want to say this API, for example, USPS SAPI is dependent on a different SAPI. You would, for a token or something, you would explain that here. In this case, it doesn't. This is just a demo. And how to use the API. So it'll be easy for somebody to come in and copy paste to Postman on like calling this API. Now, I know there's going to be a lot of resources in most cases, but just give one. You just choose one of the resources to kind of give an example. It looks nice to the business side. They like how this looks. Now, also going down to security, explain. Just saying what kind of securities you're implementing. Like, for example, client ID enforcement, where you put these on the headers. You have client ID, client secret, your normals, Now, going to your errors, just explain something simple on what your errors are, like if it was a bad request, unauthorized, a 500, and depending on situations, when it comes in, for example, unauthorized, if you're using a client ID, client secret, you would send a message saying, hey, this is, you don't have the right credentials, or you need to get a client ID, client secret, or a JWT token, that's just a simple example why we do need the error handlings right here to make things simplified. And you want to make sure when you do these good API documentations, someone that comes after you or somebody in your team will be able to use this easy and efficiently, as well as it looks good again for the business side. Also, if you have any policies, like if you're using a spike control or a client ID enforcement, put them here. If you're using also JWT, whatever you're using in your API manager, mention it here as well. And a support, like we mentioned earlier. Now, if we go here to the auto-generated, since we were talking about giving good examples, as you see here, this is Georgia State's address, so it's not mine, but this is a good example that you can put saying it's a real address, something that they can see that it's not just some blank or some random numbers or letters that don't make sense. So this is the first part of the presentation about API documentation. Also, what is it called? If anybody has any questions, oh, I forgot to mention, sorry, about tags. So please have tags that are useful when you have a lot of APIs. If you go to your assets right here and you go to your organization, you'll be able to choose like filter using these tags. So that's why it's important to have these. They look nice and they're easy to find what you're looking for. So if you're looking for a SAPI layer, you're looking for PAPI or the SAPI, you can have the tags for those and have it over here as well. So let me see if there's any questions. Okay, I don't see any questions, so we're going to continue. Now, I'm going to be talking about also Rammel and Gitz in Anypoint Studio. Now, why is this a big deal? From my experience, there has been a problem when, especially working with big teams, the team will be lost. Like, what's the last branch? Is it the develop branch? Is it the master branch within? This is within Design Center, or is it the numerical branch version? So a lot of times, people either they lose their work or it gets overwritten. So we came up with a few strategies on our own, the team and I, and we realized that okay, we shouldn't use the master branch. Always print a commit history and a publish history on the Rammel specs. Also, for us to use the latest branch numerical. Now, I'll show you guys why we don't use the master branch, because if you're having if you go to Design Center, and this is the old strategy, or there's a following up strategy that I will be presenting. So as you see here in the master branch, if I wanted to branch out, and I decide to make a change by having description type. Okay. So by doing this with Design Center on the platform, you can't just merge with the master. So what you need to do, for example, let's say your main branch would be, let's call it develop. For that one, it would, let's say this will be your main branch. You're able to delete it. By deleting it and re-having the branch, like recreating the branch, it merges everything over, your dependencies, everything over. So that's the benefit of not using the master. So let's say 1.01, I want to rebranch on that one, merge develop with 1.0.0, and that works. Now this is the old way. There is another way, which is using Studio. So if we go down here in Studio, we are able to create an API specification project. So this will act as a Git repository. So you'll be able to pull, merge, branch, and do the whole 9 yards. So let's go ahead and do that. Call it RAML API spec. So as you guys see here, we created the Rammel via Anypoint Studio. Now, this is a feature that started around like 7.4x. Let me go ahead and just have an example over here. See it all. Okay. If we save it, do commits. Make sure your commit messages are meaningful. All right, it has been pushed. Let's go check it out. So this is the one we just created. Let's open it up. And here it is. So let's say if we do a small little change, let's say we change, we add a description, address. Okay. Let's wait until it gets saved. All right, saved now. If we go to Anypoint Studio, we want to pull. So we go to team. Go here. Go to team. You pull the latest version. And you see here, the description has been added. Okay. Now, if we want to branch out, let's say we want to do some versioning. some version control right here. So we go to switch to a new branch. Let's call it 1.0.0. Finish. Let's do a small little change. Let's see what happens here. Save it. Changed. To commit and push. So if you see here, let's refresh this. And here's the change. Now, earlier I showed that it wasn't possible before to be able to merge 1.0.0 to the master. But with this Anypoint Studio, we can do that. If we go here, if we go to team, and we do switch the branch to master, you go back to team right here and click on the merge. It asks you, what do you want to merge it with? Go ahead and merge. Merging 1.0.0 to master. If we check here as well, go to master. So this is a very nice tool to have, to learn how to use. Yep. And as you see here, merge perfectly. Now, other than merging, we can be able to publish from Studio to Exchange. So we just go publish to Exchange. And let's finish that. While this is being pushed, we'll open up Exchange. Still pushing it. And here it is. So, like I said, this is a more convenient and simple strategy you can implement, and that is the end of my presentation. If anybody has any questions.
Thanks, Ahmed.
Thank you. Thank you, everyone. Thank you, Ahmed.
Thank you.
All right, so we will.
Yes, we can actually bring an existing product to Studio from Design Center. So if you'd like, I can demonstrate that. Somebody was asking a question. So.
Yes, go ahead.
Yes, let me go ahead and. Let me share my screen. So I would say the only way you can, looks like here, to do that would be to get the zip file from Design Center. So if you go into your API Design Center and you get a zip file, unless anybody knows the answer, I'm sorry, I thought I did.
Yeah, you can do a import from you do a right click on the project, so click import.
Yeah, I looked at him.
Yeah, so there is specification.
Oh,
yes.
Okay, yeah, I was looking for that. Okay, thank you. So yeah, so if you go API Specification Design Center, you search the API. And for example, this right here. Thank you for that. Oh, I already have that in my. Okay, this is. Yeah. So here's this being imported, and you have, if you wanted to do any changes. So let's go ahead and make a simple change. Go ahead and push. And here's the change as well. Thank you for the question. And thank you for the help as well. Any more questions?
Don't see any.
Well, thank you guys very much. Appreciate having me here.
All right. So if there are no more questions, I just okay. So we are good to close then if there are no more questions.
Yeah, we have some of the user looking for the information is how we are going to communicate. So we can communicate through the you have registered user. So we can look into the if your information is correct over there, we can pull your information from there and we can communicate from there.
Correct. We'll do that. Thank you, Rajneesh, for that.
So one more thing I would like to add, if you think like your information is not correct on that registered user, so please send us an email so we can correct it and then we can send that information to you.
Correct. I am going to stop recording now. Thank you.